lot due about the quiz that I know, so just coming through your classroom next week.
Yeah, any day except for Tuesday.
Okay.
I won't be here on Tuesday, so.
Did no one tell you? Oh, I wasn't sure. I don't think so. I'm not listening to the UP bio exam. Is it like Town Center? Yeah. So I had to rush to get onto the bus, and I wasn't even sure if it was still there. But I made it. You had to go to the town? Yeah, we had to go. Or we had the bus. Well, it was 1.5 hours for multiple choice, 1.5 for 4 response, and the next hour was just time waiting and
All right, guys, our bells are turned off again today, and will be turned off all next week for AP testing. But give me a second to get attendance put in real quick, and then we'll look at what's on the agenda today. Maddox. Okay, so I'd like to spend about 2 minutes looking at the handout we saw after the quiz on Tuesday, which was 121 in your binder. So that was within dealing with rational functions. We talked about what a rational function was and how to go about finding vertical asymptotes, finding holes, and finding x-intercepts / zeros. And we're going to have to add on to that today, which is why I was trying to get you to feel pretty comfortable with those before you came to class today. Just going to make things a little bit easier. But we're going to be using these just as much as anything else. So for these three, you need to make sure that you know that it can only be one of these at a time. If it's a hole, it can't be an x-intercept or a vertical asymptote. If it's an x-intercept, it couldn't be a hole or a vertical asymptote. And if it's a vertical asymptote, it can't be an x-intercept or a hole. Visually, it only makes sense to be one of each. So, vertical asymptotes, any number that makes just the denominator 0. X-intercepts, any number that makes just the numerator 0. And if it happens to make them both 0, we ended up with holes instead. So, on today's handout, we're going to start off with that, and then we're going to have to add so that we can do all of these, not just x-intercepts, holes, and vertical asymptotes, but also y-intercepts, horizontal asymptotes, slant asymptotes, graph it, and describe the domain. So these type of questions do take quite a bit of practice because the first 5 questions may not have a hole, and you may not get to practice at every single question. You may have to do a handful of questions before you find one that has a hole. Likewise, not every rational function has a slant asymptote, so we have to go through several before you can actually practice it once. But this big box at the top, I would like you to use as a location for your notes. So that way, because you'll have to lean on these a lot at first, but as you work question by question, you should be leaning on these less and less. So I'm going to start off with the 3 we talked about last time. That'll be a quick little reminder about that, and we'll have it in our notes in the same spot, and we'll go ahead and answer questions 1 and 2 with those as 2 more examples. Okay, so if I start off with x-intercepts, I know x-intercepts are when y is 0. X-intercept is a point, so my answer should look like this. And for a rational function to have a y value of 0, you need the numerator to be 0. So this is going to occur for any x values that make only the numerator equal to 0. Now, feel free to reword these, add details, add examples. But in my opinion, that's what you need to know to be able to do x-intercepts. Again, the keyword only, because if it also makes the denominator 0, it's no longer an x-intercept, it would be a whole. Okay, we had vertical asymptotes that we mentioned last class. Vertical asymptotes are vertical lines. So our answers for those should be vertical equations, x equals some kind of number. And the way we're going to find these is this is when we're trying to divide by 0. So any x value that makes only the denominator equal to 0. And then finally, the one that you should feel a little more comfortable with because of the practice from last time is wholes. And a whole is a point. So our answer should look like this. And this is going to occur anytime you can find an x value or x values plural. It could have more than one whole that make both the numerator and denominator equal to 0. So keyword in that is both. Because if it only makes the numerator, it's something else. If it only makes the denominator, it's something else. It's got to be both to be a whole. Now, probably the most common missed thing, and again, it's not that it's harder, it's just that you don't get to practice at every single question, but specifically the y value of the whole. So the x value that makes the numerator and denominator 0 is the x value of the whole. And then to find the y value is the one that students sometimes forget on the test. The y value comes from plugging in the x value into the reduced fraction. If you plug it into the original fraction, you're going to get 0 over 0. You've got to plug it into the reduced fraction. You've got to let some factors cancel out and then plug in the x value. That's how you get the y value. All right, so the first two questions won't have all three of these things, but it gives us a little bit of an example and chips away at having some of that done. So let's look at questions 1 and 2. So for these three topics, we need to know what numbers make the numerator and denominator 0. And sometimes that's really easy, like question 2. I can see the numerator 0 at 2 and the denominator 0 at 4. Question 1, I can tell that the numerator never equals 0. 1 never equals 0. 1x could equal 0, but not just 1. And then for the denominator, I have to do a little bit of work. I've got to factor it. It's got a GCF and a trinomial before I can tell you that 3 doesn't equal 0, but x plus 3 does, and x minus 2 does. So for these three things, we've got to find numbers that make the numerator and denominator 0. Now, if you know those definitions, we're about to fill out 6 of our blanks here. Any number that makes just the denominator equal to 0 are vertical asymptotes. Any numbers that make just the numerator 0 are x-intercepts. If no numbers make the numerator 0, that's a way of saying you're not going to have an x-intercept. If no number makes the numerator and denominator 0, then you don't have any wholes. So once you know those definitions, once you're not going to lean on your notes, really the bulk of the work is factoring. Now, I will admit that we need to graph these at the end, but graphing is typically the hardest thing because you pretty much have to do all of this before you start to feel confident with the graphs. But let's go ahead and add this information to our graphs and our tables. So we've got a point over here, 2, 0, so we might as well throw that on there. And then for asymptotes today, whether it's a vertical asymptote or a horizontal asymptote or a slant asymptote, we should graph them, but you should graph them as dashed lines. So vertical asymptotes are vertical lines. But don't make them a solid line because that makes it look like you're talking about the function. Just make them dashed lines. Those are actually going to be super helpful to us when we're trying to complete these graphs. But it'll take us a few more minutes to get there. Okay, so moving on. Again, I showed that to you at the end of last class so that hopefully you don't feel too stressed about those. But now we need to talk about how do you go about finding y-intercepts, horizontal asymptotes, slant asymptotes, how does all this go onto the graph? And then with the graph, how do you end up getting the domain? So I would say probably the next easiest is going to be y-intercept. And you're going to do that the same way we've been doing them all year. Y-intercepts always have an x value of 0. So to me, this is enough of a reminder because I'm just going to plug in 0 for x and solve for y. Just like we do with lots of other algebra stuff. So, going to do that for questions 1 and 2. Question 1, if I plug in 0 for the x's, I get 1 over 0 plus 0 minus 18. So negative 1/18, which is another point for the table if you had to make a table. And this one gives us our first point for the first graph. And for question 2, when I plug in 0 for x, I get negative 2 over negative 4, which reduces to a half. Same thing. Here's another point for the table if we require you to make a table, and a second point for our graph. So I would not really consider y-intercept as something that hopefully you need to study. It's similar to how we've done it all year. Okay, I'm going to come back to domain because domain's a lot easier for some people once you see the graph, and that's perfectly fine to do it after you finish the graph. The domain's not going to help you get the graph. So next up, let's talk about horizontal asymptotes. We have actually talked about the rules for horizontal asymptotes recently because we needed that for some of our limit stuff, and we needed it for something else as well. So this is where you're going to compare degrees, compare the degrees of the numerator to the denominator. Again, feel free to reword these in any way that makes the most sense to you. Compare the degree of the numerator to the degree of the denominator. And there's 3 rules because there's 3 things that could happen. We could have the degree of the numerator could be bigger than the degree of the denominator, or the degree of the denominator could be bigger, or the degrees could be equal. Those are the 3 possibilities. So when the numerator is bigger, that means your graph's either going up forever to infinity or down forever to negative infinity, just depending on other stuff. But we would say there's no horizontal asymptote. It's not going to a number. When the degree of the denominator was bigger, we said it approaches y equals 0 on the far left and far right of the graphs. And when the degrees were equal, we did y equals leading coefficient of the numerator and divide it by the leading coefficient of the denominator. Again, that all should sound kind of familiar because we needed those horizontal asymptote rules for other stuff this year, so we've already reviewed this a little bit. So again, once you know those rules and you know what you're supposed to be doing, Horizontal asymptote questions should not take you more than about 5 or 10 seconds each. So let's go ahead and do this for questions 1 and 2 and add them to the graph. So question 1, the degree of the numerator is 0. If it helps, you can think of this as 1x to the 0. There's no x's there, so the degree is 0. Degree of the denominator is 2. Anytime the degree of the denominator is bigger, the horizontal asymptote is y equals 0. That's an asymptote, so we need to graph it as a dashed line. It will help us with our graph. In question 2, the degrees are equal, so y equals leading coefficient 1 over leading coefficient 1, which reduces to 1, of course, and then we can add that to our graph. Horizontal line, so horizontal asymptote. All asymptotes need to be graphed as dashed lines. So again, not much work, but if you know the definition, if you don't know the definition, there's really very little you can do. You gotta know how those three things compare. Okay, and then finally, the last of the definition type stuff that you need to memorize is for slant asymptotes. So if your asymptote's not vertical, if it's not horizontal, but it's at a slant, this one can be the biggest pain, but luckily most of these don't have slant asymptotes. So let's first talk about when, so that you don't waste your time when it doesn't have one. By the way, also slant asymptotes we call them slant asymptotes mostly in America. I think most of the rest of the world call them oblique asymptotes. It's the same thing. Probably won't ever come up unless you do like a math contest or something. They'll probably talk about oblique asymptote, but same thing. It's only going to have one when the degree of the numerator is 1 bigger than the degree of the denominator. When the degree of the numerator is 1 bigger than degree of denominator. If that's not the case, it doesn't have one, you can just say none and move on, which is going to be the case most of the time. But when it has one, you need to know how to find it. So the how is it's going to come from y equals the quotient from long division. That's why we've reviewed that recently. And if there's a remainder, we will ignore it. And I really probably should look that up. I don't know mathematically why the remainder has no impact, but slant asymptote, if it has one, if the degree of the numerator is 1 bigger than the degree of the denominator, we have to do long division, and then the slant asymptote equation will be y equals the quotient. If there's a remainder, just ignore it. So let's go ahead and work one till we get to that. So question 1, the degree of the numerator is not 1 bigger than the degree of the denominator, so say none. Don't leave it blank. If you leave it blank, it looks like you don't know. Question 2, the degree of the numerator is not 1 bigger than the degree of the denominator, so it doesn't have a slant asymptote. And let's go ahead and move on to question 3 so that you can have one worked out for you as an example. Question 3, the degree of the numerator is 1 bigger than the degree of the denominator, so it takes me 2 seconds to know there is a slant asymptote, but to find the equation is going to take me a couple minutes. So out to the side, if I can make myself some space here. Out to the side, I'm going to do long division and try to divide this into that. Now, to be honest with you, this one has some fractions, and usually when we do these are not going to have fractions, but that's okay. It's good practice. So we need to think of a number or a something times negative 3x squared to get positive 1x cubed. So you should break this down and try to do this in like 3 parts. Think about the x's. There should be an x, because x times x squared gives me x cubed. Maybe a second step is think about whether this should be positive or negative. This guy should be negative, because a negative times a negative gives me a positive. And then finally, what number can I multiply by 3 to get 1?
1/3.
Very good. Multiplying by a third is the same thing as dividing by 3. So we multiply it to this, multiply it to this. So again, negative times negative is positive. 1/3 times 3 would be 1. X times x is x squared. You don't have to do that in one step. Do multiple steps like I'm doing. Negative times a positive is negative. 1/3 times 18 is like 18 divided by 3, or 6. X times no more x's would be an x. Change the signs before you forget and add. And it looks like we can go one more time, because there's something times negative 3x squared that gives me negative 2x squared. So notice I don't need any more x's. I would need this to be positive, because a positive times a negative gives me a negative. And if I multiplied by 1/3, 1/3 times 3 would be 1. I want it to be double that. So I'm going to double 1/3. So multiplying by 2/3 is like dividing by 3 and multiplying by 2. Just doing them both.
I have a question.
Yeah.
Would the negative x squared and the plus x squared cancel out?
This
Yeah.
isn't a plus, it's a minus.
Oh, okay.
It was originally a plus, but then when you
I see
distribute
that.
or change the signs, however you think of it, it goes to that. Alright, so this times this gives me this. 2/3 times negative 3x. I don't know. Positive times a negative is negative. 3 times a third would be 1. Times 2 would be 2. And there's an x. And then 2/3 times 18 is like 18 divided by 3, which would be 6, times 2, which would be 12. I'm kind of rushing through this part because this ends up being a remainder, which most of the time in mathematics is important, but not for slant asymptotes. Slant asymptotes, it's going to be y equals whatever the quotient ended up being. Negative 1/3 x plus 2/3. And again, some of these on this handout have some fractions like that, but most of the time you don't have to deal with fractions, but it's not going to hurt you. Now, just like vertical asymptotes, horizontal asymptotes, slant asymptotes are also asymptotes. So we should go ahead and graph that as a dashed line as well. So, and this guy is in mx plus b format. So, we've got a y-intercept of 2/3 and a slope of negative 1/3. So, just like we have practiced recently. And notice it's not vertical asymptote, it's not horizontal, which would make it a horizontal asymptote. It's at a slant, which is where it gets its name, slant asymptote. Okay, so I wanted us to have one of those down, but let's go back to questions 1 and 2 and finish these up. All right, so you've got to be able to answer these questions anyway. And again, I promise it's a lot of information. Do you guys, does this even sound familiar from last year? I know you're supposed to learn it in Algebra 2, but nobody, oh, some, okay. I'm seeing some yeses and some nos. Maybe you guys just forgot. But once I have thrown all of this stuff on my graph, I'm pretty close to being finished. Once you know a couple things, you need to sometimes get more points. I'm going to need more points for this, so we'll talk about that. And 2, you need to know how the line behaves around asymptotes, which I will tell you as well. So for points, we can just use the equation up here and just plug in some x values and solve for y. So I'm not going to pick anything crazy like x equals 10, because that wouldn't be on the graph anyway. I'm also not going to pick a half because that's going to be hard for me to do without a calculator. But I could plug in 1 without much issue. That would be 1 over 3 plus 3 minus 18, which would be negative 1/12. Also super close to 0, but a little bit further down than negative 1/18, which is going to be important. I'm still not confident that I have enough points, and as you guys, once we get to question 5 and I ask you to do some on your own, if you don't know if you have enough points, that's the best sign to know that you need more points. So I don't know, I could try -1. If I plug in -1, I end up with this, which is negative 1/18 again. And then I think maybe one more point and then I'm going to be ready to go. If I try -2, I'm back to negative 1/12. Now, most questions you're not going to need to find another 3 points, but you can plug in points all day. More points you do is honestly better. That's what your calculator does when it graphs. It just graphs hundreds if not thousands of points and throws them on there. But now we can finish up what the graph is going to do. So here's what you need to know. So here's some points. I can see that all of these need to be connected, and the direction of this makes a difference. That's why it's good to know this is a little further down than this one. So how it's going to behave around an asymptote. Vertical asymptotes, remember those are like vertical spikes in the graph. You can't divide by 0, which is why x doesn't exist here. But as you get super close to dividing by 0, your fraction gets super big. Either positive direction infinity or negative direction for negative infinity. So for vertical asymptotes, we will assume that they're going to go down on one side and up on the other side. So right here, I can see that this is trending downwards, and I have nothing to believe it's changing in here. So this one must be shooting down to negative infinity on the left, which means it's shooting up to positive infinity on the right. And that will always be the case for our vertical asymptotes. Moving towards the left, I can see it's heading down to negative infinity on the right, which means we can assume it's going up to positive infinity on the left. So that's why the vertical asymptotes help a lot, because that almost completed my graph. The last thing we need to know about asymptotes, for horizontal and or slant asymptotes, they tell us what the graph approaches as you get to the far right and far left. And so you can see it comes together very quickly. So let me say that again in question 2, even though question 2 is going to be a lot quicker because we don't even need additional points for question 2. So question 2, if you can answer that stuff above and you can throw that on the graph, you can see that it's got to go through these 2 points, so we know they're connected. If you know that it has to have this vertical spike on the vertical asymptotes, the fact that this is trending down must mean that it keeps going down. So negative infinity on the left, positive infinity on the right. And then what horizontal and slant asymptotes tell you, by the way, you could never have a rational function that has both slant and horizontal. If you think about the definitions, it's not possible. But they tell you what it approaches as x gets really small and as x gets really big. So if you wanted to plug in more points, of course that's never a bad idea. In fact, when we get to your test next week, you might plug in x equals 5, and when you plug 5 into the equation, let's say you got, I don't know, -4. If you got 5 -4, 5 -4 is definitely not on the graph. Thank you. 5 -4 is not on the graph, and so you would start to question that maybe you did something else wrong. So, but if we actually did that, this one's easy to do. If I plug in 5 for x, I would get 3 over 1, which would be 3. So when x is 5, y is supposed to be 3. So if I did that, I could make it a tiny bit more accurate, but it's already pretty good. So these won't be perfect graphs because we're not doing a million points, but they should be pretty accurate. Okay, last thing we need to do is the domain, and you're welcome to add this to your notes up here if you want to, but domain still means the same thing as it's meant all year. A way to describe the x values that make sense for this function. And to help with the first few, I'm going to do these in color down here. I can hit all of these x values, which is negative infinity to negative 3. And then I can hit all of these x values, which is negative 3 to 2. And then I can hit all of these x values, which is 2 to infinity. Again, for some people, it's easier to answer that once you have the graph. You can see what x values you're skipping. And that's just a long-winded mathematical way to say skip negative 3 and skip positive 2. We're skipping negative 3 right here because we're taking numbers less than negative 3 and bigger than negative 3. And we're skipping 2 because we're only taking numbers less than 2 and numbers bigger than 2, which again just means we're not taking 2. If I do the same thing over here, I can hit all of these x values from negative infinity to 4. And then I can't hit this one, so I can hit all of these, 4 to infinity. Again, just a fancy mathematical way to say you can plug in anything you want except 4. Now to do domains, you technically don't need a graph to do domains. You're just taking out any x value that gives you division by 0. So domain could care less what it looks like. It doesn't care if it's a whole or a vertical asymptote. But if you can't plug in that and get a y value, it has to be taken out of the domain, which will just be wholes and vertical asymptotes. So notice we took out 4 from the domain, we took out negative 3, and we took out 2 from the domain. Okay, I'm going to go over 2 more questions with you from scratch, but obviously it's not going to take as long because we already have the notes filled out, and I can say the rules for these things 50 times, but to be honest with you guys, the third or fourth time I say them is probably not going to help more than the first or second time I say them, which is why I like you to have it written in that box on the front page. But when we get to question 5, again, just follow along with me for 2 more questions, and then I'll let you kind of work at your own pace for a few minutes. I'm going to suggest start with whatever ones you feel most comfortable with. I personally think y-intercepts are the easiest. Plug in 0 for x, solve for y. So that's what I would start with. Then I would say these take a little bit more work, but I know I can knock all 3 of these out at the same time because they're basically the same work. But for these, I'm going to need to factor. Looks like we've got a GCF and a trinomial in the numerator, and a GCF and a trinomial in the denominator. If I set each factor equal to 0, there's 3 numbers that make the numerator 0, 2 numbers that make the denominator 0. Negative 3 never equals 0, so that doesn't give us 1. Bless you. Now, of course, that takes a minute to do that, and you don't need to try to factor as fast as I do. But at the end, a second you get that done, you should be able to answer these very quickly now. Any numbers that make just the denominator 0 are going to show up as vertical asymptotes, or spikes in the graphs. Any numbers that make just the numerator 0 are going to be x-intercepts. And which one of those should make sense to us? Which one of the x-intercepts should make us feel good about our work so far? Right, because the origin is not just an x-intercept, it's also a y-intercept. So it's good to see that consistency there. And if there was any number that made the numerator and denominator 0, we would get a whole. Now notice this is 3 questions in a row that doesn't have a whole. This is why you have to practice a handful of these, because you got to do a bunch just to get to practice whole a couple times. Alright, the degree of the numerator was 1 bigger than the degree of the denominator, so it did have a slant asymptote. We already did the long division to find the slant asymptote. An equation, a rational function can't have a slant asymptote and a horizontal asymptote at the same time. Again, if you look at those definitions carefully, you'll see why. But also the degree of the numerator is bigger than the degree of the denominator, so no horizontal asymptote. Now, if you'd rather do the domain at the end, you're welcome to, but I can just look at the numbers that make me divide by 0 and take those out. The first number I would skip is -3. The second number I would skip is 2. But if you feel safer once you see the graph, then of course do the graph first. Alright, and if this stuff is right, my graph should make sense. If something's wrong, my graph is going to be very complicated. I'm going to be trying to make things fit in ways that they don't fit. But I know the point 0, 0. I know the point 3, 0. I know the point -2, 0. I've got a slant asymptote that's already graphed. I've got a vertical asymptote at x equals 2 and x equals -3. You're encouraged to get more points. Sometimes you need to get more points. But on this one, I think I actually have enough points. Because, so again, this is probably the most important part, because in 30 seconds this whole thing is going to be graphed. If I know it hits this point, and I know it has to approach horizontal or slant asymptotes, I know what this looks like. Based on this direction, I can see that this graph is going to infinity on the right side of the vertical asymptote, so -infinity on the left side of the asymptote, which is good news because I want it to come up and hit this point. Again, all of this should be consistent if it's right. And then he must turn back around to go to this other point that I know about. And now that I know this direction, I can tell it's going to -infinity on the right side, so +infinity on the left side of the vertical asymptote. And again, horizontal and slant asymptotes. The most common misconception here is that you guys think that you can't cross those. You actually can, especially if your graph has a left, middle, and right. Your graph could cross the slant asymptote in the middle. That's why sometimes we need points in here. But at the ends of the graph, that's what it should approach. So, not perfect. If I wanted to look a little better, I might plug in x equals 1 so I could see like how steep this is. This doesn't look the best. I don't know, I might plug in -4 to figure out how quickly this kind of hugs these asymptotes. But all things considered, that's pretty accurate for how much time we would put into it. Okay, so one more, and then I will have you try the next one based on what you think. But I think y-intercepts are the easiest. Plug in 0 for x, solve for y. Done. I like to do these 3 next. It's just my preference. So I would need to take a minute to factor, to figure out there's a couple numbers that make the numerator 0. -4 doesn't equal 0, but x plus 3 does, and x minus 1 does. And because I know the definitions very well, I'm going to be able to use these with almost no effort. Numbers that make just the denominator 0, vertical asymptotes. Numbers that make just the numerator 0, x-intercepts. and numbers that make both the numerator and denominator 0. Finally, we get the one that has a whole, is the x value of the whole. Now the part in your notes that I encouraged you to elaborate on was the y value of the whole, so I'm going to rewrite this to make it a little easier to see. To find the y value of the whole, you need to plug in the x value of the whole, not into this. You're going to get 0 over 0. That doesn't help you figure out the value. You need to reduce your fraction and then plug it into what's left over. So negative 3 minus 2 over negative 4 times negative 2, which would be negative 5/8. And while that might seem like, how does that help us with the graph? It actually will. Even though it's not going to hit that spot, we do have to graph it, and it does help us figure out what the graph looks like. Okay, slant asymptotes. The degree of the numerator is not 1 bigger than the degree of the denominator, so no slant asymptote. And then horizontal asymptotes, the degrees are equal, so y equals leading coefficient over leading coefficient. Again, I'm not trying to like blow past you guys by saying the rules quick. I'm just trying to show you that if you really know the rules, there's not a ton of work to be done. You apply it, get your answer, put it on your graph, and move on, basically. The domain, come back and do after the graph if you want to, but I can see there's 2 numbers I need to take out of the domain. There's 2 numbers that don't give us a y value on the graph. So the first one I would skip is negative 3, and the next one I would skip is negative 1. So that's what the domain is going to be. Yeah?
What's the y-intercept of 1/2 instead of negative 1?
If I plug in 0 for x's, I get 0 plus 0 minus 6 over 0 minus 0 minus 12, and negative 6 over negative 12 should reduce to 1/2. And you can either put this stuff on the graph as you find it or at the end like I'm doing, but I've got some points like the x-intercept, 2, 0. I've got the y-intercept, 0, 1/2. Even though the whole is not going to be a point on the graph, we need to show it as an open circle. So when x is negative 3, y is almost negative 5/8. Make sure that's clearly a whole, clearly an open circle. I've got 2 asymptotes that I can graph as dashed lines. And then if I feel like I need more points because I don't know what's going on, that's fine. But this time I think we've got enough. These have got to be connected. Based on the direction of this one must be going up on the right side, down on the left side. Even though it doesn't hit the hole, it's going to hit the points right before it and the points right after it. So that helps me connect that. And then all horizontal and slant asymptotes tell you is the y value it approaches as x gets really small or as x gets really big. And then before you know it, your graph is done. And then last thing I would suggest is you can check most of this by checking it in a calculator and graphing. I don't have my classroom calculators today. They took them for the AP Stat test and for the AP Calculus test that's next week. Oh, I still have this graphed. Okay, so you could graph it in your calculator, or if you have your Chromebook, you could graph it in Desmos.com, use theirs. But I changed the window settings from -5 to 5 and -5 to 5, just like our graph. But this is the one we just worked out. And if I compare this to mine and just do a 5-second eye scan, they should look the same. I see one vertical asymptote in the right spot. I see one x-intercept in the right spot. calculator doesn't do a great job of showing holes, but I could do trace, what was it, -2? No, -3. Yeah, at -3 there's a hole. You can see y doesn't exist there. So if the graph you made up is that close to the actual graph, then that's a good sign. Obviously, if it crosses the x-axis more, that gives you a hint about what you did wrong. If there's more spikes in the graph, more vertical asymptotes than you thought there were, then that gives you a hint about what you did wrong. So the graph not only helps you check, but it also helps push you in the right direction. Okay, I would like you guys to go ahead and try question 5, please. And again, well, one advice I would give you on question 5 is if you miss this negative out front, your graph's going to be upside down. So you might want to change this and put it next to the 4 so you don't lose it. But I think you should start off by just starting with the ones you feel most comfortable with. To me, that's y-intercept. Might be something different for you. And then try the next most comfortable, and then the next most comfortable. And at some point, you're going to need to flip back to the front page and read some of the rules or read some of the definitions, and that's fine. Do that. But then on question 6, try to lean on your notes a little bit less. And when we get to question 7, try to lean on your notes even less. As long as you actively try to absorb the note information when you have to look at it, you will see that you don't need them over time. So I am still going to go over a few of these with you, but I want you to try them from here on out before we go over them. So we've got about 55 minutes, and I need you guys to get through at least question number 9. So what I'm going to do is I'm going to set a 10-minute timer, and in 10 minutes I'll go over question 5. I think 10 minutes is probably a little bit too much time. So as you finish question 5 or as you get stuck on question 5, go ahead and just move on to question 6. Don't just sit there and be unproductive. Go ahead and move on and take care of the parts that you are comfortable with. And then after we go over a couple of these together, if you would prefer to check yours by graphing, if you have your own calculator or you want to pull up Desmos on your Chromebook, if your graph looks the same, again, that won't promise that your holes are correct, it won't promise that your domain is correct, but it should verify that the rest of it's correct. So, all right, so I'll bug you again in 10 minutes. I will go over question 5 to help you out with whatever parts you're still missing. Oh, one other thing to consider here too is this is the last of the new information, not just for this unit, but for the semester and for the year. So a little bit more light at the end of the tunnel than normal. So honestly, you could probably go home and practice past question 9 and be in pretty good shape for the next test. And other than maybe reviewing for the semester test if you don't exempt it, you're pretty close to being done with this class for the year, at least in content that you have to learn. Also, for those of you doing calculus next year, sometimes these questions do show up on calculus exams. The mock exam that we did this year, one question literally says, how many vertical asymptotes would this rational function have? And that's not anything to do with calculus. It's just one of the things they expect you to remember from past courses. So. I'm gonna go over this one with you now. So if there was parts of this that you struggled with, or you tried to check your graph and it doesn't look the same, then let me help you figure out what it was, because whatever's holding you back is going to continue to hold you back for several more questions. So, all right, y-intercept, the part you have to memorize is plug in 0 for x and solve. When you do that, you get -4 divided by 0, which doesn't make sense, which means that there's not going to be a y-intercept to this graph. I can factor the numerator and the denominator. The numerator never equals 0. -4 and 0 are never the same thing. And the denominator equals 0 at 3 and 0. So there's no numbers that make the numerator only 0. That would be x-intercepts. There's no numbers that make the numerator and denominator 0, which would be wholes. But there's two numbers that make just the denominator 0. Bless you. So those will be vertical asymptotes. Vertical asymptotes and wholes need to be taken out of the domain. So I need to skip 0. And then skip 3. Oops. All right. Think about the rules for horizontal asymptotes. The degree of the denominator is bigger, so it's going to be y equals 0. And slant asymptote is the one that takes a few minutes, long division, keep the quotient, ignore the remainder, but only if the degree of the numerator is 1 bigger than the degree of the denominator. Not the case here, so that's not going to have one. All right, as far as your graph goes, unfortunately you have 0 points, it looks like, but you've got 3 asymptotes. You've got x equals 0, x equals 3, and y equals 0. So you can't really start your graph if you've got 0 points. You've got to have some points to know where your graph is somewhere in here. So you've seen that I don't have to do this every single time, but I definitely need to here. So I would make a table if there wasn't one already made for us, and I'd start plugging in easy x values. If I plug in 1, I get -4 over 1 minus 3, which would be -2. So when x is 1, y is 2. Now, so I know one place where my graph is supposed to be, but I still don't really know the direction my graph is going. So again, I have no idea. I'm just going to pick something else and go with it. If I try to do -2, I would get something that looks like this. This reduces to -2/5. So when x is 2, y is about -2/5. And this is going to bring up the part that students sometimes struggle with. This graph has 3 sections. There's a left section, a middle section, and a right section. On the far ends of the graph, your graph should not cross the horizontal or slant asymptotes. But in the middle, it certainly can. Sometimes it does, sometimes it doesn't. You never really know until you plot some of these points. So let me double check that I did this right. I did not do this right. Sorry, that point was wrong. That would be -4 over 4 minus 6. So -4 over -2 is also 2. So be careful with that. I thought the graph was about to do this, and it's not. But it is possible to cross horizontal asymptotes and slant asymptotes if your graph has a middle section, just not at the ends. I don't know. I think I've probably got enough to roll with this now, but again, there's not going to hurt you to plug in an extra point or two. I'm not doing this with the calculator or anything. I'm not doing anything special, but just to show you, it doesn't take but a second to get a few more points. And again, if this is correct, everything should feel like it kind of fits together. If your graph seems really confusing and it feels like you're trying to make something work that doesn't really work, that means you did something wrong. But I've got plenty to get worked with now. I know this point has to approach the horizontal asymptote on the far left. This point has to approach the horizontal asymptote on the far right. Based on the direction, I know where it's going down and up on both vertical asymptotes. I know it's got to go through these points. And the last guesstimate that I would make, although I guess you could try to do 1.5, but of course fractions are going to be a little bit harder, but it's going down here and then it's got to come back up. So something along those lines. Okay, and then of course the best and quickest way to see if you're on the right track, graph it. Now we won't allow calculators on that test because otherwise you could just graph it from the beginning and not know what you're doing. But my graph compared to the calculator's graph, if at a glance they look the same, then that guarantees that most of this is correct. Again, it wouldn't guarantee that the domain's right. It wouldn't guarantee that my hole is right because the calculator doesn't do a great job of showing those, but it should mean everything else is fine. Okay, is there anything specific about 5 you'd like to ask or you'd like me to go back over? Okay. Then if you have not moved on yet, go ahead and move on to question 6. And again, I don't think it will take you 10 minutes to go all the way through 6, but I will go over it 10 minutes from now. So. But please approach it the same way. Start with the things you feel good with. Use the notes on the front page for the things you feel less comfortable with, but try to remember them each time you look at them. All right. So I'm going to go over this one again. So obviously if you feel okay, you can go ahead and keep on going. But the ones I would check off pretty quickly would be y-intercept, plug in 0 for x, solve for y. These three are the ones we need to know the values that make the numerator and denominator 0. You might want to factor the denominator to be a little careful there. There's no number that makes the numerator and denominator 0, which is how you get a whole. There's one number that makes just the numerator 0, which is how you get an x-intercept. And one number that makes just the denominator 0, which is how you get a vertical asymptote. Wholes and vertical asymptotes are the two things you need to take out of domain. So I need to make sure I take the numbers less than -4 and bigger than -4. Since -4 is the only thing we can't plug into this function. Horizontal asymptote rules, the degrees are equal, so it's going to come from y equals leading coefficient over leading coefficient. And slant asymptote is only if the degree of the numerator is 1 bigger than the degree of the denominator. Yeah.
How do you do the leading coefficient of the leading coefficient?
So this would be, so coefficient just means the number that's being multiplied by something. So like 5x, the coefficient is 5. Leading coefficient means the number that's being multiplied by the x with the biggest exponent. So the leading coefficient of the numerator is 1, and the leading coefficient of the denominator was -4. And that's where I got -1/4.
I have a question.
Yep.
Wouldn't that be the same as the derivative?
No, that would not be the derivative. Derivatives get more complicated if you're talking about a big fraction. If you were doing something like this, the derivative would be -1/4. But we have something called the quotient rule when you want the derivative of a fraction. But you'll learn that in calculus, so for another day. All right, we throw on the y-intercept, throw on the x-intercept, dashed line for vertical asymptote, dashed line for horizontal asymptote. Looks like that's all the information I have to go with. Sometimes more points are good, but this one I think we're good to go because these got to be connected. It's got to approach the horizontal asymptote to the far right. Based on these directions, it's still going up, which means it must be going to infinity on the right side of the vertical asymptote, so -infinity on the left side of the vertical asymptote. And it's got to approach the horizontal asymptote on the far left also. So not a perfect sketch, but pretty good for a about 4 minutes worth of work. X minus 4 over -4x minus 16. Okay, and their graph compared to my graph looks good to me. Again, it's not going to be 100% perfect, but it should be very close. If it's not super close, then something's definitely wrong. Okay, other questions you guys have? Okay, I will, so I'd like you to do at least 3 more of these, please, 7, 8, and 9. You've got almost 25 minutes to do so. Obviously, if you guys find a question, then go ahead and ask, but I'm going to ask you guys to try to check them from here on out by graphing in a calculator. And I do have one calculator up here, but if you're going to do that, then maybe graph it and then come up here and use it so other people can use it. You can also use Desmos online. But I'd like you to do those 3. If you can't do those 3 with how much class time we have left, then please finish that up for homework. And I will see you guys again tomorrow because it is a B week. So. Well, if there's an asymptote there, there's an asymptote there because there's not going to be a value at that point. Yeah, something's off there. Well, it can only be one of these at a time. X equals 3 can't be a hole and an x-intercept at the same time. A hole is where the graph is missing, and an x-intercept is where it's hitting the graph on the x-axis. Those two things contradict each other. So what numbers make your numerator 0? And 0. X equals 0 is 0.
Yeah.
What numbers make your denominator 0? Okay, so it sounds like positive 3 makes the numerator and denominator 0. Correct?
Yeah.
So that means that 3 is a whole and not one of those two. That's where on the definitions I emphasize the words both and only. If it's both, it's a whole. If it's only numerator, it's this, and only denominator is that. You can't do more than one at a time.
Well, yeah, I just, it was wrong. Well, if I got fractions. were working on the rate, but I forget, we think it's asymptotic. Something you wanna do on it.
I think I messed up again. In terms of I got a horizontal asymptote, and then I also got the y-intercept and the x-intercepts on the thing. I'm pretty sure because it's only. Would I just not have a y-intercept and that?
I think that's okay, because you've got two vertical asymptotes. So you're gonna have three sections of your graph. You'll have a middle, a left, and a right.
Uh-huh.
Your graph should not be crossing the horizontal asymptote on the ends, but it can cross it in the middle. And I bet this 0, 0 is probably crossing in the middle of the graph.
Yeah. Okay.
So I think it'll be fine.
Alright, thank you.
Yeah, you can see on the other side. No, that was the first map, that's all. So we did that. Yeah, you can just cancel those out at the start. Yeah, okay.
All right, we've only got a few minutes. So again, I need you to get through